Hello, myself Sandeep Bhad, Assistant Professor, Department of Electronics and Telecommunication Engineering, Runta College of Engineering and Technology, Bhilai, affiliated to Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome you course on Fundamental of Communication and its application. Today's our topic of discussion is mobile cellular network. Hope you have been learned about the basic overview of mobile communication and some standardization in last previous lectures. Let us talk with the content of these lectures. First we go with the objective of the lectures, then the why cellular system, concept of frequency reuse channels, carrier to interference, that is CI ratio, co-channel interference reduction factors, handoff mechanism, some concept of cell splitting, and we also deals with some new generation cellular topology. Now let us come with this objective of these lectures. Once you go with these lectures, you will be able to having the detailed concept of cellular networks for all wireless standards, some frequency reuse concepts, handoff mechanism, and the new topology for cellular system. In mobile communication, the bandwidth utilization is most important parameter. If the frequency spectrum usage is efficient, such system is said to be best system. In the design of system, there are many fundamental elements available. The elements it contains the concept of frequency reuse channel, carrier to interference ratio, co-channel interference reduction factors, handoff mechanism, some concept of cell splitting. Now let us come with this the one by one. It is quite difficult to manage the frequency resources, so as to serve the maximum number of users with the good system quality. The cellular system should be efficient to serve many users to talk, and also should be proper planning frequency utilization. A better cellular system should provide a maximum number of cells per hours per cell and maximum number of channels per cell. Also the maximum number of call per hour per cell. To find out the number of call, that is approximately in 1 hour in one cell, the detail we required, one is the size of the cell and the traffic condition of the cell. If the size of the cell is n is small, it will influence the number of calls made in 1 hour. It is better to have a cell of 2 km radius. Let us consider that in the cell of 2 km radius, the vehicles are moving around. The vehicles are 10 meter space in busy hours. Also, the 8/10 of them, that half of the vehicles are provided with phones, and total number of vehicles is about 270,000. In one half of the vehicles with phone, it is assumed that the call in the busy hour of the day is n equal to 0.8. In this case, 28,000 calls are possible in 1 hour with the assumption that one call per car in hours is to be made. Depending on the geographical area, the cell, the number of calls made in busy hours will differ. Now, the second will the maximum number of frequency channel in one cell. The allocation of number of frequency channels to the base station of each cell is important scenario. The maximum possible number of frequency channels in one cell is highly rated to an average calling time of the cellular system. If the maximum call in 1 hour in one call is q, then the offered load is A, may be calculated from the relation that is given by the offered load equal to A, that is q into T by 60 Erlangs. The trunking theory was developed by Erlangs and offered load is expressed in Erlangs. Now, let us assume that the maximum number of call in 1 hour, that is q, and are 3500. An average calling time, that is T, is 1.76 minutes, and the blocking probability is 2%. The offered load in this case will be A equal to 3500 into 1.76 divided by 60. It would be A equal to 103 Erlangs. Here, one important point to be noted that the frequency utilization in cellular communication has to be planned effectively to serve many users within the given band. The offered load would be appropriate if the frequency management is high, that is, best bandwidth saving should be planned. Now, let us discuss about the concept of cellular system. As a matter of fact, with the limitation in the spectral width, the maximum number of users, that is we call as the capacity, that can be supported in the wireless mobile system is an important performance measure. If the system is supported by a single base station, a high power transmitter required to support a large number of users. The system capacity, that is number of users, can be arranged by arranging a small cell, each requiring only a low power transmitter in a cellular array. Here we are increasing system capacity. The increase in a system capacity comes from the use of smaller cell, reuse of frequencies and antenna sectoring. As discussed earlier, the wireless propagation channel exhibits impairment for more so than those inherent in guided wire. The several impairments means that the wireless channel yield to proper or poorer signal to interference ratio, that is we call as a SIR, and hence higher transmission bit error rate, that is called as the BER at the output of the receiver compared with those in the wired channel. In a wireless channel with multipath feeding may be in the range of 10 to the power minus 2 to 10 to the power minus 3. So, this error rate is defect completely based on the feeding of the channel. This high error rate has an effect of limiting the amount of throughput and rendering the signal reception unreliable. Impairment in the propagation channel will result in the reduction of usable spectral width. Mitigation of interference due to channel impairment has the effect of allowing spectral width. A wider spectrum in turns means more bandwidth to support more users. Certain sophisticated modulations and coding techniques have built in properties that the receiver can exploit to the compensate for channel impairment. If a single transmitter were used to cover a large geographical area, a very high power transmitter and very high antenna would be required. All users will share the same set of frequencies of radio channel. The system capacity in terms of the maximum number of users that can be supported offered by single high power transmitter hit a limitation. The reason for this limitation is that the radio resources, that is frequencies, are not effectively utilized. It means whatever frequency we allocated, that will be not utilized properly. If the same set of radio resources where another small ensure that use of same set of frequencies to serve more than one geographical area does not introduce the reception interference between user in the two areas, or if there is some interference, it must be at an acceptable level. It means whenever we use the frequency in both areas, their interference should be less, then and then we can say that is acceptable level. This means that the geographical region that use the same set of radio frequencies must be physically separated from each other. So, that the power level of signal that spill out from one region to neighboring region does not produce unacceptable interference. This way of replicating gives a rise to the concept of cellular communication. A geographical region can be single small area called as a cell, that is served by single base station or cluster of cell. In cellular system, each of the base stations in the cluster is connected to mobile switching center, that is called MSC, by wire lines, and MSC has more computing power and can perform many more functions than individual base station. Therefore, most of the communications operations are handled by MSC. There is also BSC, that is called the base switching centers, which handle all the base stations. As we come to know the traditional system and their limitations, cell is nothing but a geographical area. What should be the shape of that cell? Let us know something about the cellular fundamentals. Please see the figure 1 in a presentation. You will be able to see there the triangular and rectangular shape of the cell. This is kind of the topology or shape of the cell we are going to use in a first time. For cell of same shape from the cluster, so that there are no ambiguous area that belongs to multiple cell or no call, or we say as the cell shape can be only 3 type of regular, polygon, equatorial triangle, square or regular hexagon as shown in figure you can see there. The triangular and rectangular, the kind of topologies has been given in a figure, you can check the presentation. Here you will find the when you have the number of cells connecting with each other, there should not be a remaining area should be there, right. Even you will find in the next figure, there you will find the hexagonal array of cell. Here you will find this is the best suitable the topology for cellular system for dividing the geographical area. A hexagonal cell is the closest approximation to a circle of 3 and has been used traditionally for the system design as you will find in a figure. The argument for hexagonal shape comes from the fact that along the 3 shapes mentioned, for a given radius, the largest possible distance between the polygon center and its edges. The hexagon has the largest area. By using hexagon geometry, the fewest number of cells can be cover a geographical region, and the hexagon closely approximate a circular radiation pattern which would occur for omnidirectional base station antenna and free space propagation. When using the hexagonal to the model coverage area, base station transmitters are shown. You will find the either being the center of the cell or the center excited cell, or 3 of the 6 cells vertically, that is edge excited cell. In practice, the omnidirectional antennas are used in the center excited cell. That means, you will find the base station is in between the cellular system or in between the cell, that is used in a corner excited cell. Somewhere you will find the edges of the, or we may say at the corner of the cell. This is nothing but the center excited and the edge excited. Also in practice, the consideration the usually do not allow the base stations to be placed exactly as they appear in a hexagonal layout, because this layout is completely on a ideal basis, but practical considerations are different. We have now well known about the cellular concept. Now let us discuss about the important fact, that is frequency reuse channel. This is the most important factor. It completely rely on the cellular network. Because of the frequency reuse, we can go with the scarcity or the whatever scarcity we have a spectrum, that is minimized. Now let us discuss this the concept of frequency reuse system. Any cellular radio system mainly depends upon an intelligent assessment and reuse of channel, that is the frequency reuse. Throughout the coverage region, you will find these all 2 parameters are very important. Every cellular base station is assigned a go of radio channel which are used within a small geographical area called as a cell. Further is adjacent cell, the base stations are allocated those channel group which contain the complete different channels than neighboring cells. The base station antennas are designed to achieve a desired coverage with an particular cell. Also, we can limit the coverage area to within the boundaries of a cell, so that the same group of channel may be used to cover a different cell which are spaced by separated from one another by distance that is large enough to the interference level within tolerable limit. In short, the designing process of selecting and assigning channel groups for all the cellular base stations within a system is termed as frequency planning or frequency reuse concept. In cellular radio systems, the channel allocation, reuse systems, or we may say as a reuse scheme, are very important, has been the leads to the bandwidth saving. In cellular mobile communication, Each channel is assigned with a group of channels, but a group of channel allocated for one cell will be different from group of channels allocated for a neighboring cell. Every cell is provided with its own base station. Each base station is designed to provide better performance with smaller number of radio channels. The design process involved in allocating and reuse of frequency channel is also called as a frequency reuse techniques. The number while planning the number of radio channels is also called the footprint, or when we having a cell planning or channel planning, one should consider about how much area it will cover. The area which will cover by the cell is nothing but a footprint, that is we call as the radio coverage of cellular area of the required for hexagonal cell. In the matter of fact, in mobile communication, the direction and separated in time or frequency, so as to the channel available in plant and channel will be assigned for every cell. There are two types of kind of systems, one is a time division multiplexing, another is a space division. In time division, the frequency reuse concept could be applied in time domain. In for phase domain, in case the same frequency is divided into several time slot and used, it is called the time division multiplexing. But if the space domain we use the same frequency will be allocated to various geographical regions. Also same frequency range, goal of this concept is to save bandwidth with tolerable interference level. The geographical is used repeatedly, that is known as frequency reuse concept. Now let us talk about the number of users in the system. How to define this number of users in a system? The number of user in the busiest hour of the day should be high, as users should be allowed access the system even in the busiest hour. So, that the grade of service that is called as GOS of the system may be very good. So, here the requirement of GOS is good, as the number of users can be made a call during a busy hours. So, this is the main important factor here. The traffic conditions of each cell drive the maximum number of call possible in hour in a cell. If the maximum number of frequency channels are being assigned to the each cell, then it should provide the maximum call in 1 hour in a one cell. The number of call possible has to be monitored by the system continuously, and enough offered load should be made in the entire system. Now, let us talk about something, the co-channel cell, adjacent channel cell and co-channel interference. There are two clusters you will find in the figure shown in a presentation. Here you will find the cluster size is 7. The cell of same alpha weight in the two clusters use the same group of frequencies. They are called as a co-channel cell. For example, in a figure you can see the presentation A of a cluster 1 and A of a cluster 2, that is called as a second is called as a co-channel cell. Within cluster you will find another one cluster, but the cell B to G in the cluster is called as a neighboring or adjacent cell. Thus, interference due to co-channel cell is called as co-channel interference, and the interference due to adjacent cell is known as adjacent channel interference. So, here there are two terminologies, one is a cluster of cluster and co-channel. Here you will find the neighboring adjacent cell and co-channel cell, there are two terminologies. Based on that, whatever interference is generated, that is naming as co-channel interference and adjacent channel interference. Now, let us talk about something, the detail of co-channel interference reduction factor. How to reduce this co-channel interference, what should be the design consideration, how that cell will be planned, what should be the frequency planning, what should be the distance from one tower to another tower, that is what exactly. When there is interference due to co-channel cell, it is said to be co-channel interference, that is generally called as CCI. When the distance is less between the center of co-channel cell, the interference generated cell available if the size of cluster is 7. Here you will find we have taken a n equal to 7, that is the cluster size, and when the level of interference is higher, then the wall be more. In the hexagonal cell in the system, there will be a 6 co-channel interference ratio of carrier to interference, that is called as C by T, or we call as the carrier to interference CT. At the mobile units, due to 6 cell sites in the first tier would be same as their interference at the center of the cell. When the level of interference is higher, then the ratio of carrier to interference, this to be valued of will C by I will be close to each other. If any local noise is present, it would be less than the interference level, and hence the local noise, if it is there, if or any, we may neglect those systems, or we may neglect those noise which the level is very less. Now, just talk about something, the cell splitting. This is also the one of the important topic related to the cellular network. What is the need of that cell splitting? So, cell that we know very well, cell is nothing but a geographical area, and when we have a good or best system, one should go with a proper planning of cell, a proper planning of frequency, distance, right, and the right topology should be choose for cell splitting. As a matter of fact, the main goal of the cell splitting is to achieve efficient spectrum utilization. This is one of the most important topic. In mobile communication, the bottleneck is the bandwidth, right. In cellular system, if there is a high density traffic, that particular cell may not be able to handle all the calls, then if the cell is split into smaller cell, the number of call can be distributed among of them. In umbrella cellular pattern, there are macro and micro cells. The macro cell is split into several micro cells. The micro cell handle the high speed traffic, and micro cell is meant for low speed traffic. If the cell is split into smaller or micro cell, then we have a new cell radius, that is old cell radius by 2, and new cell area, that is old cell area by 4. Now, let us talk about the type of cell splitting. As there are the major two parts of cell splitting techniques, one is a permanent splitting, another is a dynamic splitting. What exactly permanent splitting? In a permanent splitting, the techniques where before the process of splitting, all design as per the planning has to be fully completed in advance. The channel allocation, transmitting pose, traffic load, consideration have to be done at the first step itself. During the lowest traffic, that is midnight, the actual service cutover has to be set. Due to this, there is a chance of minimum drop calls. This cell splitting techniques is a fixed one and does not entertain change in a channel allocation according to the traffic load. This is what exactly about the permanent splitting. The second one is the dynamic splitting. In dynamic cell splitting techniques, the allocation of channel are done in real time practical field. Depending upon the mobile traffic requirement, the allocation of channel cell site is done by transmitting the request for channel and acknowledgement signals between the BTS of the respective cell site and to the mobile switching center, that MSC and BSC, that BTS is responsible for arranging the cell. During the heavy traffic load times, all the channels would be used to meet the demand. Thus, in dynamic cell splitting, there will be no ideal channel in cell site. Now, let us see about something, the drawbacks of permanent cell splitting. There are few drawbacks, that is, if the traffic is low, then there is a chance of unused channel in a cell site. Thus, utilization of radio spectrum is not good. The technique is less popular than the other one due to insufficient bandwidth uses. Now, Let us talk about the one new parameter that is completely important with the cellular patterns. Without this handoff mechanism, one cannot go with uninterrupted service. So, what is that exactly handoff mechanism? The handoff refers to the process of transferring an active call from one cell area to the another cell area, involving a switch from one channel to the another, typically at requiring change in a carrier frequency and time slot. It is initiated due to reason like signal strength deterioration or network traffic congestion, and can be either synchronous or asynchronous. So, there are again various reasons for handoff. Out of those, we are considering only two, that is, one is once the user is away from the network and there the signal strength get deterioration. Second one is if the number of users is accommodated in a in a one cell, or you will find a heavy traffic intensity in a particular cell, that time that BTS or BSC stations cannot handle more calls. So, they will refer called as a handoff, it will transferring to the another cell. So, this is what exactly the handoff system. Actually, this handoff system will be done within a 60 millisecond. So, the process is what exactly, if you will find there are two towers, tower A and B, and user is moving from A to B, during the time the mobile set whatever handset he is having, there is a complete calculation available inside the telephone, and the bit error rate goes on increasing. So, what exactly that bit error rate? It means once the user is go away from the cellular system or the tower, he will find degradation in a network, the radio links will get interrupted. So, that is the once the error rate get increases, and you will get a less kind of signal that will be detected by the tower, and the mobile cell is operating in whatever channel, he will request to the next incoming or the whatever network available during the locations, he will request to that particular the BTS stations, request for channel. Once he will request, he will check whether the channel is available or not. Based on the availability and the error rate and the user moving from one end to another end, the one signal strength get decreasing and another signal strength get increasing. So, but obvious your handset will be connected with the increasing radio systems or increasing signal strength. So, that can be decision will be taken by the BSC, and both the cell requesting the channels, one is for the termination, another is for the connections. So, once your channel get disconnected from the previous or the old cell, that time it will automatically connected to the second cell, and this way you will find the handoff will be done. So, there is a one midpoint that is called as the handoff margin. At that point, you will find the both tower signal get same. So, there will be the decision will be taken by the mobile system, the which signal should be taken. Now, let us discuss about the new topology that is generally we are currently using 4G and 5G. The 5G operates across the wide spectrum of the bandwidth and support various number of use cases. That wide spectrum will allow the wireless carrier to conceptualize a large number of development options to their needs. 5G will operate in two frequency ranges. The first frequency range, that is 410 megahertz to 7.1 gigahertz. The second frequency range is 24.25 gigahertz to 52.6 gigahertz. The development options for wireless carriers can be ranges from macro cell, that is for coverage, to the small cell for capacity. So, macro cell we use for the coverage and a small cell we use for the capacity. Wireless carrier will consider capacity coverage, mobility and spectrum availability to decide their development strategy to determine whether they will go for macro or small cell. Let us now understand the definition of macro cell and small cell. Macro cell typically provides coverage to a large geographical area. They are typically installed on rooftop poles and some instant on ground based towers. The major advantage of using macro cell is 5G is that It can provide a 5G service to a large geographic area. 5G macro cell also use massive MIMO technology, which allow a large transmission and reception of the data. Second one is a small cell. Small cell has been used to deploy the legacy of technology like 3G and 4G and would play a more important role in 5G development. It will empower wireless carrier to deploy cell site in strategic location and offer higher capacities in small coverage area. Now, let us talk about the new topology, that is femtocell versus picocell and microcell. Femtocells are very small mobile base stations that are used to extend coverage in a residential or small office complex. They are used in an area with network congestion and it acts to offload a microcell. It can also serve to the provide in a building coverage. Picocell. Picocell are a small cellular base stations covering area like building, hotels, hospital and shopping malls. It is generally used to extend the coverage and increase throughput. Then we have a microcell. Microcells are generally a bit bigger comparison to the pico and femtocell. They can support more number of connected users and cover a greater geographic area. They are mostly used for enterprises premises. Some small cells forecast challenges and opportunities. Let us talk about the what challenges and the opportunities available with this cell forecast. One of the major drives for the small cell market is the introduction of CBRS, that is Citizen Broadband Radio Service in private networks. Both LTE and 5G networks is gaining a business potential which can beef up a small cell deployment. With millimeter wave 5G development taking a shape of commercial network deployment, small cell will play a major role in paving a success story of 5G use cases. Now, what are the challenges are available, how that 5G system get facing, but the major challenge in the rapid small cell deployment will be backhaul connectivity. The small cell will be deployed to capture the increased capacity in residential or enterprise premises where commissioning of fiber can be challenged. The proper bandwidth, if backhaul is not available, it can be potential bottleneck. Therefore, to tackle the issue of black holes, the wireless carrier need to think of alternate backhaul options like satellite and high capacity microwave. Now, let us see something about the opportunities in a new cellular system. One of the major opportunities for small cell is that since transmitted power for small cell is quite low, the mobile terminal will also need to be operate in a small power, which will enhance the better battery life of the equipments. This will improve the performance of the mobile handset too. Now, these systems completely you will find femto, pico, macro and micro cells will be available in a different kind of systems. Nowadays, you will find some distributed antenna system. These distributed antenna systems and small cell both complement each other in 5G development. This is a complete private and enterprise space. The DS is a network of antenna that are connected to the common RF sources and then distributed to the customer premises. They are generally used in a large sporting stadium or event where there is a higher definition or diffusion of cellular network. Now, we have learned something the new topology about the DS system. DS is generally you will find the mall area in everywhere you will find where the basements are there, the RF signal will be get distributed in a different areas. So, this is what about the cellular network system. Now, let us conclude this lecture. A cellular network is a widely deployed infrastructure for wireless communication that enable improved spectrum utilization, enhanced network capacity and proximity based services. A well renowned understanding of cellular system, sales topology, frequency reuse, co-channel interference, handoff mechanism, various cells type like femtocell, macrocell, picocell is essential for optimizing modern wireless communication networks. Cellular systems are structured network or interconnected cell, each with specific frequency allowing efficient use of limited spectrum resources through a frequency reuse. This reuse, however, introduces co-channel interference which must be managed to maintain a signal quality. Handoff mechanism ensure the seamless connectivity as users move between cells. The different cells type ranging from small femto and picocells to larger microcells play a distinguished role in enhancing network capacity and coverage. This concept collectively contributes to the robust design of cellular networks accommodating growing demand for wireless communication. Hopefully, this article has given you an insight into the world of mobile communications, the basic of cellular networks and what it meant for the mankind. Thank you for listening the lectures.